With a mass and mole stoichiometry problem, what you're going to have is you're going to have either your answer that needs to be given in grams or the given number is going to be given in grams. So in either case, if you have grams or need grams, we're going to have to do a conversion with the mole like we did last unit. So we know that the heart of every chemical stoichiometry problem that we do is that mole ratio. You have to do a mole ratio to get from moles of your given to moles of your unknown. The mole ratio comes from a balanced chemical equation. So in order to go from moles of your given to moles of your unknown, that's where we're going to fill in that ratio. Now the difference with these problems versus the mole-to-mole problems that we just did, like I said, in the first question here it says we want to know how many grams of oxygen are produced. In the last problem we just gave our answer in moles. So what we're going to do is we take our moles and we convert it to grams in the end. We learned how to do that last unit by finding the molar mass. The molar mass is 1 mole of anything, and that is just taking each of the different components and adding it up to fill in this blank for your conversion factor. So on all of our problems, if you have grams in the beginning, you have to get rid of grams and go to moles. Or if your answer ends up in moles and they want grams, you're going to take those moles and convert it to grams. So somewhere we're going to have to convert from or to grams. So in this first problem, it says 1.50 moles of potassium chlorate decomposes into potassium chloride and oxygen. So I need to first write out my balanced equation because I know I'm going to need my mole-to-mole ratio. So potassium chlorate decomposes into potassium chloride and oxygen. Now my next step would be to balance this reaction. So I'm going to put a 2 and a 3 to balance out my oxygens, and then balance out my potassiums and chlorines like that. So we have a 2, and a 3 for my coefficients. So we're going to start with the number that's given in our question, which says that we have 1.50 moles of KClO3. So my given is moles on this problem. And when I'm given moles, I can go straight to my mole-to-mole ratio to go from moles of my given to moles of my unknown. So my conversion factor, I need to get rid of moles by pulling in my coefficient, so 2. And I want to know how many grams of oxygen. So I'm going to put moles of oxygen up here because I eventually need to get to oxygen with a mass. So there's a 3 out front there. So what that did for me was it converted my moles of KClO3 into moles of O2 or oxygen. But the question doesn't want moles for oxygen, it wants grams. So what I'm going to do is one more step using the molar mass of oxygen. When I get the molar mass of oxygen, I'm going to plug that in this step down here, and that'll help me do my conversion. So the conversion says 1 mole of oxygen has a molar mass. We would need to look that up. Oxygen, I really don't need a calculator, but we'll pretend like I do. 1 oxygen has a mass of 16 plus 16. That's going to give us 32 for a mass. So moles of oxygen is now gone. That leaves me with grams of oxygen. So now to get my answer, I'm actually going to multiply all the way across the top. So I'm going to take 1.50 times 3 times 32, hit equals, which is 144, divided by, so hit divided by, I'm going to open up parentheses, 2 times 1, close parentheses, and hit equals. The answer that my calculator told me is 72. I have 3 sig figs here, so you should have 72.0 grams of oxygen for an answer. Now on the next problem, it says using the equation in problem 1, so we already have a balanced reaction right here. You have 80 grams of oxygen being produced. We want to know how many moles of KClO3 decomposed. So on this one, they're giving us grams. We want to know how many moles. So we're going to go from grams to moles. To go from grams to moles, I first need to use this conversion factor to change my grams into moles so I can get to my mole-to-mole ratio. So the molar mass, fortunately we found it right here for oxygen, so I don't need to calculate it again. There's 32 grams of oxygen in 1 mole of oxygen. So all I did was convert grams to moles. Now that I have my moles, now I can go from moles of oxygen to moles of potassium chlorate. To do that, I need my balanced equation. So for every 3 moles of oxygen, I have 2 moles of the KClO3. So that got rid of moles of oxygen for me. That leaves me with moles of potassium chlorate, which that's what the question asked for. So I don't need to do any more math. So now I'm just going to plug this into my calculator. And I take 80 times 1 times 2, it equals, divided by, I'm going to open up parentheses, 32 times 3. Close up my parentheses because we have to multiply everything on the bottom. It equals, I had 3 sig figs to start with. I need to round this to 3 sig figs. 1.67 moles of KClO3 is my answer. So with these mass and mole problems, the only difference is we're either going to have our original number in grams and we need to get rid of grams to go to moles, or your answer is going to need to be in grams, so you'll need to take your moles, convert it back to grams. So in either case, you need your molar mass conversion.